So we're just waiting for everybody to get here. We started a little bit earlier today because we started a couple minutes pretty much right at the wire yesterday because I was having some trouble.
This gives everybody a chance to be, promoted to panelist.
Yeah,
oh,
come in,
Teddy,
test
yes,
your
absolutely.
sign,
No problem. So
test your sound, do all that stuff.
yeah, if you're a student, you will get promoted to come into the room. There you go. Kane, hello, Kane. Good to see you, Teddy.
Hi.
Teddy's
I'm
here.
at the library, so that's why everything looks different. There's no video.
Library, it's one of my favorite places.
Oh, okay.
I took my dog for a walk this morning and I actually walked right past our library, but the dog can't go in, so we just
You should walk around and invite people to sit in with you.
Hi, Kane.
Kane's here. We'll wait for a minute or two.
Yeah,
Got all kinds of stuff today. We're going to do some housekeeping before we talk about it.
Question? You got a question, Kane? Go
Go
ahead.
over a couple things.
Are we talking about elliptical galaxies today?
We are. We kind of talked about them a little bit yesterday, so we're going to talk about them again today in greater detail. We had some lively discussion yesterday about these objects, and I thought about some of what we discussed. So we're going to talk about them again today. And a lot of it has to do with how these things are classified. And, well, we'll wait for a minute or two. But we're going to talk about elliptical galaxies.
Teddy, question.
I just wanted to say I made my own astronomy Kahoot yesterday.
What was that?
I made my own astronomy Kahoot yesterday.
Oh, very good.
Did. Oh, that's exciting. Lots of fun.
So I think we'll ease into it and just get started. Anybody else who's on their way can join us when they get the chance. So I want to go directly to Slooh, to the webpage right now, and take a look at our workspace. I know we had some new people join us and they were added to the workspace. The easiest way that I can think of to find the workspace is just hit the little icon of yourself and it takes you right to the bottom of the page, My Workspaces. And we're looking for a summer astronomy camp. And the reason I'm stopping here is because I want to see what people have been posting. Okay, so we have a new image. This is of the Orion Nebula. I'm going to like that. And we had talked about this. Kane was talking about the sunflower galaxy. I already like that. Kane, what did you find out about the sunflower?
I was looking into it a bit yesterday. It's a mess. It was cataloged in the Messier catalog.
That's right. And what type of galaxies, what did you find out for us?
The best I could find was it was a I forgot what that was. I can.
That's okay. The reason I bring it up is because you had mentioned that this was a live mission yesterday during camp, and we weren't able to get over to the telescope in time. But I talked about flocculent galaxies. Those are those galaxies that are flaky in appearance, where the spiral isn't as well defined. It starts to spread out a little bit. And this is actually one of those. It's not as noticeable in this picture because of the atmospheric conditions and those kinds of things. They can interfere with the way that we see certain objects on Slooh. But if I'm not mistaken, the sunflower is one of these flocculent galaxies. So I'm just showing the workspace again. They're having people added to the workspace. So if you're new, you can take a look down there, make sure your name is there, and you can start contributing and posting images. Certainly encourage everybody who is part of the workspace to go through. So Pikachu, I know who that is. That's Teddy. This was the picture of the moon that you were talking about. So, and let's just take a quick look at this. Yeah, so this was a full moon picture. Pretty good, nice and clear. Do you have anything to add, Teddy, to what you did here? It's full moon, right out of the textbook, right?
Yeah, my mom did figure out how to get submitted without an error message, but yeah, I took it on Canary too, and I just thought it turned out really well.
Yeah, it did. This is very crisp, and I'm seeing some things here that we're going to talk about when we have Moon Week. I'm seeing something called libration, favorable libration. That's a fancy word that tells us that we will hear that we only see one side of the moon, and the other side of the moon is hidden from us because the moon orbits the Earth at the same speed that it spins on its axis, and because of that, we only see one side. That's not completely true. We don't see 50% of the moon. We can see up to 59% of the moon because there is a little bit of a wobble in the moon's orbit around the Earth. And I'm seeing it here. We're seeing, this is the crater Endymion, and this is Mare Voldianum. And there is a sea here. This is Mare Crisium. There is a sea here, Mare Marginis. And we're kind of seeing part of that. So we are seeing some favorable libration. We're going to talk about that during Moon Week. But just get into the habit of looking for these little secrets, these little hidden things that we see in our Slooh images that are serendipitous. Fancy word, right? That means coming across things that we weren't searching for, but serve us very well in our journey through space. So Teddy, I'm going to give you a like. So once again, everybody go through some of these images and take a look. All right. So I promise.
Observation on the full moon. It's an observation. I'd like if people would like that so that I could get 10 likes. I have like 6 right now. So I have to look a little back because I posted it.
Yep, I gave you likes, so that's the way it works here, right? If when one of us posts an observation in the workspace, everybody more or less agrees to go back and take a look at it. So I promised you an image yesterday of this person. This is Henrietta Swan Leavitt. Does anybody remember what she did and why that was important? I didn't have the image load, but we did talk about it.
She she was a person who discovered some things in space, galaxies.
Pretty much, yes. She is somebody who discovered a new way to calculate the distance to stars and objects that are out in space, not just stars, really deep sky objects. The old method was to use some form of triangulation or parallax, which can give us about 200 light years away. She came up with a method that would put us, in a way that we could calculate the distance to galaxies. And that's where Edwin Hubble came in. He was the person that began to realize that Immanuel Kant in the late 18th century with his theory, and remember, he was not a scientist or an astronomer, he believed that these things that we were starting to see with more and more powerful telescopes, better telescopes, greater clarity, were in fact galaxies, island universes, as he called them, not things in our own galaxy, but things outside of the galaxy. And it was this man, Edwin Hubble, that pretty much proved that idea. And he came up with that Hubble tuning fork that we talked about. First thing you notice, of course, was that these galaxies that he was seeing, these faint fuzzy objects, had different shapes. And he came up with his tuning fork diagram, which everybody can make here if you take the quest associated with Edwin Hubble. But we're going to go right to where we left off yesterday. we talked about some of the spiral patterns, and we had some lively discussion about what we felt individually about how these objects came about and what their morphology is, right? How they develop and age over time. So this is where we left off, elliptical galaxies. So these are galaxies that are older than spiral galaxies. Hubble, if you look at his tuning fork, I think he kind of thought, now they say, I read different things. They say, well, he didn't really think this. He just used this tuning fork model as a guideline for classifying shapes. The reason we call this a tuning fork, does anybody know? This looks like a tuning fork if you tune an instrument. Before digital tuners and quartz tuners, usually you would have a tuning fork, a set of forks if you were tuning a piano, or one or two forks if you're tuning a string instrument, and you went by the pitch that the fork gives when you hit it. And that's what it looks like. It looks like this. Has a handle and then a double fork that you hit, and that's what gives the vibration. So, did he think that elliptical galaxies came first and then they became these spiral galaxies? I don't know. Probably not. We know that that isn't the case. At least we think it's not the case. And we go back as we come to the end of the class about maybe, I thought about this last night, didn't keep me up, but I did think about it. You can make an argument for spiral galaxies developing out of elliptical galaxies, but we'll talk about that. Anyway, so he began to look at these elliptical galaxies that he saw, and he realized a couple of things. Just like spiral galaxies, when we see something like this, that's an edge-on view, and then we have the face-on view, right? Depending on how we look at it. Edge-on view like this, face-on view where we see the whole thing in the spiral structure. Well, these elliptical galaxies have the same type of pattern, where it could be oblong, it could appear that way if it's face-on, but if it's viewed edge-on, you may be looking at the nose. It doesn't matter that it's long like this to that side. You may be just looking at the front and you're just seeing the circle. So he came up with some ways to classify these objects, and we can see E1, 0, E1, E2, and further you go, the longer the elliptical object becomes, the elliptical galaxy, this ball of fuzz. E0 is pretty much a perfect circle or a sphere. And then we get this kind of cigar shape, this lozenge shape. And he came up with a formula for a way that he could calculate and give him these designations, everything from E0 to E7. We've never talked about formulas here, but Dr. John does give this formula in his Hubble Quest, so I thought we would take a look at it. So you'd look at the height of the object and the length of the object, and he gives this formula. N is 10 times the object in parentheses, so the order that we do mathematical functions. Please excuse my dear Aunt Sally, we do what's in parentheses first. So B over A is 3 over 10, that's 3/10. 1 minus 3/10, 1 is 10/10, so it's 7/10. And this example shows it converted to a decimal. 7/10 times 10 is 7, and we get the E7 classification, just like in the picture. Saw how it was a lot longer than it was wide. All right. And then we have this other classification, which is kind of an in-between thing, this lenticular galaxy. My laptop is not updating. I don't know what you guys see here.
We're seeing the view of the face-on and the edge-on lenticular galaxy, S0.
And maybe it's just my laptop that's a little slow. That is what I use as my screen. So anyway, the same idea as an elliptical galaxy, but not technically an elliptical galaxy. He called these lenticular galaxies because if you look at it from the side, it does look kind of like a lens. Face on, you're not going to see that, but from an edge-on view, you do see that sort of convex effect above.
Keith, I think you locked up. Are you there?
Yeah, I'm here.
Okay, perfect.
Good.
There's
So let's take a look at some of these. We're going to take a little Slooh break. And okay, I have to open up my Slooh. Sorry. And I'm going to show you why we're doing this. So we had a pretty good showing of what we have with spiral galaxies and grand design galaxies and specialized galaxies like flocculent galaxies, different types of spiral galaxies. So I wanted to go here to look at some of these elliptical galaxies. Now, I was watching a show the other day that somebody hosts, and they didn't have telescopes, or they had telescope views that weren't all that great, which was a shame because rather than go with bad images, all you have to do when you're going live like we are today, and you need to find something, is go up to this magnifying glass. That is a search bar. All right, now I'm going to do something here. I'm getting grief from my monitor, which is my laptop, so I'm going to reload that. But I'm still live here with you guys. So I'm just going to type in the search bar. I'm not even looking for a specific object. I'm just going to type elliptical galaxies, and we're going to look at some. And you will see the wisdom behind my doing it this way. All right, so you can see I have a menu of elliptical galaxies. I didn't schedule any live elliptical galaxy missions because a lot of these are listed as NGC numbers and catalog numbers. Elliptical galaxies are a fairly recent discovery, okay? We knew them as blobs, we knew them as a type of nebulous cloud through a telescope, but we didn't really identify them as galaxies. It was very easy when we see spiral galaxies to know that they're a type of galaxy, but these not so much, and I'm going to show you what I mean. So this shows us the page of illuminations, which are poems and short stories and star parties, and I want to go to observations. And this is where I'm going to see a whole bunch of M49 elliptical galaxies. So let's just take this one and blow it up. As you can see, there isn't a whole lot to write home about this. It's just kind of this fuzzy patch with a bright center. This image is more or less the same thing. And this image is more or less the same thing. The same thing. We get an idea of what M49 is all about. Let's go back. Let's go back to some more elliptical galaxies. Let's look at, let's kind of play this game. Let's look at M59. Didn't we just look at this? Okay. Okay, this is a really nice image because we see some other galaxies nearby. All right, I'm going to file that little piece of information away. Let's look at another one. It's the giant elliptical galaxy M87. These are the types of things that I like to do when I'm at home and we don't have telescopes. Okay. All right. So we looked at three differently named three separate elliptical galaxies. Is anybody seeing a pattern? Can anybody identify where I'm headed with this?
They all look like blobs.
Exactly right. How would you say this differs from the spiral galaxies that we talked about yesterday?
Can you repeat that?
We looked at all those beautiful spiral galaxies yesterday, these grand design galaxies. How would you say that these are different? You said they look like blobs, so which is what they look like. So explain to me what you mean.
Because you don't really see the arms like the spiral galaxies do. They more look like clusters of stars, like a star cluster.
That's a nice observation. They do kind of look like what we would call a globular cluster before telescopes were powerful enough to resolve globular clusters into individual stars. That's the term we use, resolve. They just kind of look like this. So if you go out with a telescope and you don't have enough light gathering capability, it's not really magnification so much. It's you need to have a certain opening in the telescope to be able to gather enough light. You just kind of see a blob, and all elliptical galaxies, more or less, look like this. So my whole point with this is, don't be disappointed when you're filling out, let's say, looking for objects in your Messier catalog quest, that you keep coming up with pictures like this, because this is what elliptical galaxies look like. They don't get much better than this. They are going to appear as balls of fuzz. They don't resolve into anything. And you'll notice another thing. They usually have this type of, when we have color, this type of orangish tint. So we don't have spiral arms. We don't have really anything. It looks like this hazy, fuzzy patch with a bright central core. I didn't realize this myself when I first started using Slooh. I was working on the Messier challenge, which I never completed, by the way. And I was working on the box galaxy, which is not technically an elliptical galaxy. I think it classifies as an irregular galaxy, but anyway, it's the same thing. Every picture I got, every mission I ran for almost a year came out looking like this. And it was then that it occurred to me that this is what elliptical galaxies look like. You're not going to get much better than that. You may get some pretty things in the background. You may get stars, you may get other galaxies. But as far as the object itself goes, we don't see very much. And it's kind of like when we talked about dark nebulosity, where sometimes the objects can be very faint, very difficult to see. And that's just the nature of the object. We'll look at one more. So not only does this show us how similar elliptical galaxies are to each other, what's going on with this? Okay. But it also shows us some things that we can do when we don't have live telescopes, or we want to get an idea of what an object looks like before we go crazy and scheduling missions. Know your neighbor. So again, we see some type of gravitational interaction here. We'll come back to that. Let's take a breather here for questions or comments on elliptical galaxies. We're going to take a look at why these look like this. But to do that, I've got to stop sharing for a minute and go into my little animation that I have. What happens with thoughts or comments on these elliptical galaxies? Seeing a comet amorphous, that's a very good term to describe what's happening. Amorphous meaning not really having a defined shape, anything like that. Other thoughts on these elliptical galaxies? Kind of disappointing? I don't think so. You're going to see why. They're very interesting when we understand why they look that way.
Some of them actually have, even some of the small ones, have some star formation. Because I remember like reading about a paper about a nearby small elliptical galaxy, and there was actually star formation in the core happening. It was NGC 185, which is a satellite of Andromeda. That was quite interesting.
Yeah, let's take a look at the animation here, and we're going to come back and talk about some of these scenarios and share thoughts. Like I said, we had a very lively conversation about this yesterday, and it was so good, in fact, that I thought we would kind of do something we don't normally do and have a type of roundtable discussion about the origins of some of these elliptical galaxies and what the future holds for them in their life cycle. because there isn't really a whole lot to say about them because they're all more or less the same. I'm going to share my animation. What happens? Why do they look this way? It's because of this. You have two galaxies or two galaxy-like objects that enter into a collision course. So this is from, my cursor's not out of the way there, but it is here. Okay, no more. So this is the Andromeda. You can see Andromeda coming here from the left. Now, this is a problem that I have with this animation because Gabriel, you're right. This probably should have been absorbed at some point already. I'm not sure why this is showing itself out here. And the animation will show us that all the way through. So Andromeda and the Milky Way will begin to attract each other. And Triangle is part of this too. And this is what's going to happen. You're going to have this interaction where they're going to perform this dance as the gravitational attraction to each other overwhelms and passes through, and there's going to pass through again. And you're going to reach a type of equilibrium, and the gas will start to heat up, and these stars will enter into that, that red giant stage, and the gas is heating up, so we're having some of that orange color. Triangulum will probably be absorbed first, I would imagine, by Andromeda. So this simulation isn't perfect, but I think it's still good to watch because we're going to watch it again. I enjoyed it so much. We think about this. Now you can see the bar in the center. So we do have an older galaxy here. The Milky Way is believed to be a barred spiral galaxy. And when we think about collision, the stars in each galaxy are so far apart, it is unlikely that there's going to be any type of actual collision. I mean, stars crashing into each other. It may happen, but that's not really what's going to happen. It's the idea of one galaxy passing through the other, the force and the speed and momentum, carrying it through to the other side until it kind of gets drawn back in, and it does that little dance until it reaches a type of gravitational equilibrium and reforms into this elliptical shape. So we will lose the spiral arms of each galaxy as it fuses together and becomes this new object. And we'll just watch it again. So I don't know. I like this graphic. I like seeing what actually computer models tell us is going to happen. It's not a collision as much as it is a passing through each other and then becoming a new object. Love it. Now we see the stars being spread out in space. The fact that we know this is going to happen, and the fact that Andromeda is only 2.5 million light years from us, we can assume that this action is pretty much already happening. Out on the spiral arms, we have to imagine that there is already distortion, that stars are being tugged at, pulled at from different directions of these two, or really three galaxies interacting. And not just them, but also these dwarf elliptical galaxies. And then we have to throw in the globular clusters and this tug of war really between everything surrounding. We're going to go back and look at that local group picture to give us a better idea. But that's what's going to happen. They're going to pass through each other until the cores kind of reach this equilibrium and everything kind of coalesces, becomes this blob out in space. And that's what most elliptical galaxies look like, right? It's got the bright central core. We have all this material on the outset. We've lost the spiral arms. Everything's just kind of in a type of mix here. Okay, we got some chat questions. I don't understand why a galaxy type EO evolves to an E7. To me, it should. I don't think we'll go back to that. I'm not so sure that the galaxies become one or the other. I think of it as just having this shape. And I would imagine the shape has a lot to do with what it has sucked in and how it was formed, and, you know, the angle of the object coming into it. I don't like to use terms like evolve when we talk about a lot of star stuff. I prefer the term life cycle, because there's nothing to suggest that EO becomes E7. When we looked at that diagram, you know, what's really happening there? The shape of what we see is going to be based upon where we are in relationship to it. And that final shape is going to have a lot to do with how the elliptical galaxy formed. You know, what is crashing into, merging with other, you know, with the other thing, and how many things are involved, and that kind of thing. It's like stellar, like the life and death of stars. I think that's a much better description, a life cycle of stars, as opposed to an evolution, because the star isn't changing into anything, right? It's still a star. It's just that it's growing, it forms, and then it goes through its main sequence phase, and it grows, then it gets older, and nuclear fusion stops, and then it becomes a red giant, and, you know, that whole thing. And depending on its size, it may blow up or become a planetary nebula. So, you know, I don't think that there is a development along this line. I think it's either one or the other. Not to say that it can't be that, but I think of it more like that. We're on the subject here. What did I want to share? What did we want to look at? All right, I'm gonna have to X out of it. Guys have so many questions. It's hard for me to, okay, to me. So it's a classification. Yeah, I don't think it's necessarily anything to do with it passing through a timeline. That doesn't mean that it can't go through changes as it's tugged at, but I think of it more as a type of classification with ellipticals, because ellipticals have all undergone that change. I'm looking at more slides here. Where do I want to go? I don't know. Bottom of the hour, let's take a break. Questions, comments, thoughts. Let's have some participation. Tell me what you guys think here.
Relating to your point of like evolution, I mean, I know what I see what you mean, and I think it's true that they're not really evolving. It's a life cycle. But I mean, just saying, well, I mean, in science, in like the papers, we usually like just talk about them if stars as like evolving into from one stage to another stage, but they're always still stars.
Yeah, you know,
Yeah.
I think that's a good way to think about it. You'll see that used all the time. You know, evolution is a word that's, I think, overused, and it's kind of a crutch, I think, that a lot of people fall back to and use it as a term. I think life cycle is so much better when we think about what's happening with a star, because you know, it's what happens, you know, in that, and it's what happens with galaxies. It's what will happen with our own sun. You know, they still are by nature what they are. So it's just how I think of it, and that's kind of what I do when you know, if you're stop by the Tuesday show or stop in any of the astro classes, I always, you know, give a little bit of a twist and think about things in slightly different ways, because, you know, as I said yesterday, especially when we get into this elliptical galaxy stuff, a lot of it is up to speculation. It's really only, you know, certainly this side of 100 years that we even knew what they were. They were still thought of as being fuzzy patches, and, you know, in the sky and through a telescope, that's what they look like, and that's certainly what they look like here on Slooh. Despite the fact that we have a half-meter telescope, that's a pretty serious instrument. Okay, that can give us a limiting magnitude of about 20. Limiting that magnitude, if you've not heard that term before, it's how deep can we see, how faint an object can we detect. So if even the Slooh telescopes are seeing these as a ball of fuzz, that's a pretty good indication that that's really all there is to see. I know what I wanted to look at, and I saw some hands up, and now I forgot. I know what I wanted to look at. I wanted to take a look at our model of the local group. But in the meantime, while I find that, Kane, you had a question, so go ahead.
So the elliptical galaxies. So do elliptical galaxies start as a different kind of galaxy because if they're older?
Perfect question for my graphic here. So this was our image of the local group. So this gives us an idea of what's happening. We have spiral galaxies. We have the Andromeda. We have Triangulum. Then we have these other things. We have globular clusters. We have elliptical, dwarf elliptical galaxies. That's kind of what we see up here above Andromeda. So there is gravitational influence with these objects that are around the perimeter, that are around the large galaxy. So it's not too hard to imagine that, you know, our galaxy has an influence upon all these objects here. And some of these objects are larger and smaller, and some of them will attract the smaller objects closer to them. So that's probably what happened in some of these dwarf ellipticals. They may have been a small, very small galaxy or a type of galaxy. Remember, we talked about globular clusters being more galaxy-like than being, you know, a star cluster-like. Globular clusters may have black holes at the center of them, some of them. So, you know, you have all this stuff going on. You have this very large parent galaxy, but you have these other types of attractions going on with some of these smaller objects that are, you know, in the general area. So, you know, the larger galaxy is just going to continue to absorb these smaller galaxies, and these smaller galaxies will begin to absorb each other depending on where they are. So, you know, elliptical galaxies, yes, they're older, and the result of these types of interactions with some of these other objects until they get absorbed by the larger galaxy. And the relationship with the larger galaxy doesn't mean that they will absorb the object completely. And we see that here with the Magellanic Clouds, which is a southern hemisphere object, definitely visible in the night sky. There's some great pictures online if you look, where you'll see large and small Magellanic Cloud, probably in a relationship with the Milky Way galaxy, maybe torn apart, maybe misshapen. Maybe that's why we have that kind of shape, not completely sucked into the Milky Way yet. Will that happen? Yeah, it probably will. And we see that with Andromeda, and its companions. So, you know, we have to think of all this as, you know, an organic type of relationship. You know, it's not like this spiral galaxy becomes an elliptical galaxy. It's very gradual over a long period of time as things get sucked in and passed through. I mean, this thing that's going to happen with Andromeda, you know, it's not like there's going to be a collision like a car hitting a wall. You know, it's going to happen over a very, very long period of time. It probably has already happened. It's probably happening now. There's probably already some, you know, gravitational sharing between our galaxy and Andromeda, certainly Andromeda and Triangulum, and probably our galaxy between all three. And certainly you can see how they're clumped together, right? I mean, it's not too difficult to see that, yeah, all these things are kind of in a relationship with the Milky Way, and all the stuff around Andromeda is in a relationship with it. And the Triangulum, which is a flocculent galaxy anyway, it's already losing its spiral appearance to us and has a low surface brightness, will probably merge with Andromeda before we merge with all three, but maybe not. But, you know, that's the whole point with these elliptical galaxies. You know, more than any of these galaxy types, I would say that less is known about these because there isn't a whole lot to see. There isn't a lot of detail, and we certainly don't have those beautiful spiral shapes, but it does have characteristics of other galaxies. I have to pull up another slide. I didn't plan on talking, well, I did kind of plan on talking about this. Let's take a breather here. I have to go back and dig through some of my images here. Gretchen, this is a good time for you to give a plug about whatever you want to talk about for a minute or two. while I look for my supernova images.
Right. Yeah. So, coming up this week, we've got Galaxies. And of course, don't forget to come on Thursday for the Kahoot. And it's great when you're here live because, of course, you get your gravity points. But I was also looking, there's supposed to be some auroras showing up in some part of the country this week, but I can't remember where that was. So I'll have to look at that. And also, you guys, we're going to be awarding some points for posting in the workspace. So if you've got photos that you want to post, we're going to start giving you guys some points for that. So get active.
I've got
in
a
the
question.
workspace.
Sorry.
Oh yeah, Gabrielle, what do you got?
Well, I mean, I'm honest. I'm gonna be honest. I don't really know how this actually works. I just looked through like some things to see, and then there's the Iris Nebula in 5 minutes. It says it's in 5 minutes. I'm not really sure how to like take pictures.
Let's do that right now. Let's go to the Iris Nebula. What telescope are we on?
Should I share a screen?
I've got it. Yeah,
I'll share the screen for you.
It's already, I see some laggers. So what telescope are we on? First of all, you have to find out where it is. You go to the observatory icon, Iris Nebula. I'm guessing Canary 2 or Canary 1.
No, I'm not sure actually.
Well, I will figure out how that is. So
We are turning it.
sorry, Bob. Turn him off. You go to the queue. That tells you what's coming up next. Okay, it's not. How coming up is coming up close? Like within the next. Anyway, this is what you do. There are two telescopes with Canary 2. You go wide field or the ultra wide field.
Sorry, is it Canary 1 or 2?
I'm not seeing it in either one. Iris, okay, 225. So this is what we've, oh, that's not the Iris Nebula. It sounds like a minor planet. Is this where you wanted to go, to Iris? That's the minor planet.
Hold on. Oh, sorry, I was just listening. Sorry, there was just like some voice to my constellation Leo.
I'm not seeing it here. I will say this as we talk about how to find things. The Iris Nebula is one of those very faint reflection nebulae that are difficult to capture, which is why if it were me, I would schedule it for Canary 1, but I'm not seeing it here. But I will talk about some things that you do. We'll just use this as an example. Let's say you want to schedule a mission or join a mission on Canary 1. You have to be, I think, 10 minutes or so outside of the mission. You'll see 3 dots. We can join that mission. And then we'll go back. So I'll show up as being part of that mission. When you join a mission, that gives you the ability to not have to be there live to take pictures. If you want to take pictures live, all you do is you see the camera icon and just click on it. I'll take 2 or 3. It doesn't matter whether you've got the ocular view or you go to the whole image. It saves it as both. And your image will show up right at the very top. And you can also find it by going into your photos. So if you go up to your little avatar, click on my photos.
Just wondering.
Yeah, no, this is an important question. If you're new to Slooh and you haven't figured these things out yet, believe me,
Okay.
this is such a time saver. So I'm going to backtrack. I'm going to do this again for your benefit, for anybody else who's new. So this
Sorry,
is what you see.
Sorry, I
This
just
is
have a
what you
quick
see.
question.
Go ahead.
Just like, is there like an all sky like view, or is it just some objects?
Yes,
And
there
like
is an all
the
sky camera. Let's do this first.
oh no, I could
All right, we're
answer
going to get
questions
into
a bit.
this. Is good because elliptical galaxies are kind of boring. I think it's more important to figure out what it is that we do when we're on Slooh. So let's go Slooh telescopes 101. This is the single most important thing that anybody needs to know, especially if you're new to the interface. Once you reach this app.slooh.com and you're on this main dashboard, this little observatory icon here is what takes you to the telescopes. Green dot means the telescopes are online. Chile 1 isn't online yet. They just don't come online until later. So that doesn't really mean anything. Right now, we've got all of them up. Canary 1 is a telescope. Canary 3 is a telescope. Canary 4 is a telescope. Canary 2, I'm going to stop here. These are 2 telescopes. So when you join a mission to Canary 2, you get 2 for the price of 1. You get the wide field telescope, and we'll go to the queue. Oh, here's something here. Spiral Galaxy M90. So we have a wide field, and we have the ultra wide field telescope. So when you schedule missions to the moon, you want to look for the ultra wide field telescope. This is the tab you want open. And let me get rid of this. There is no limit to the number of tabs you can open on Slooh. So I'm going to open up another tab.
Sorry. Wait, sorry, I'm sorry, could you please repeat what you just said? Because I just like went on.
Yes. This is important.
Voiceover.
No, it's okay. This is important to know because a lot of people bang their head against the wall. I did, pretty much everybody does, because we don't realize that each of these tabs represent a different telescope. So with Canary 2, we have 2 telescopes. This is extremely important when you schedule moon missions, because if you're looking for the wide field telescope, you're not going to see anything. The full moon image, just meaning whatever phase the moon is at and seeing the whole moon in the field of view, is the ultra wide field. There isn't a moon mission now, but that's something to file away. You will see missions scheduled to Canary 4, which I'm going to do this side by side. Here we get a zoomed in image. Sorry, I gotta turn off the audio. I don't know if we have any moonshots. Moonshots are, the moon is very close to the sun right now. We're past the last quarter, so we won't see moon missions till later in the night. But when you see Canary 4 moon images, you're zoomed in. So if you're working on the lunar features quest, that you want to use Canary 4. If you're working on the lunar phases quest, you want Canary 2 ultra wide field. This may seem kind of confusing in the beginning. This will become second nature for you in a very short period of time. But I think the important thing to know is that there are different telescopes suited for the job. And with Canary 2, we have 2 of them. Same thing on Chile 1. We have a wide field and an ultra wide field. I know for a fact Canary 2, the ultra wide field telescope, is a TeleVue 85. That's a refractor, provides great images. Canary 1, it was the TAK 90. It was Takahashi 90, Sky 90. But I heard through the grapevine that they're going to change that telescope out. Either way, you have 2 telescopes. How do you take a picture? You go to the camera icon, click on it. I'll do 2 here just so you see it. The picture on the telescope page is available immediately. You can also find it from My Photos, the photo roll. So that's the 101 part. The all sky camera part, what an excellent question. This is all kind of advanced stuff. So if we want to see the all sky images, we go to, again, the telescope, but we want to look, I think this is good. We have the all sky view right here. and you could look at the time lapse. This is under live, so for if we're using the queue, that just tells us what missions are upcoming. The live view will give you the all sky, and you can open the time lapse and see what we saw. So we see the sun starting to set before it gets dark. If you want to learn about the telescope, there is a part here that tells you what's going on. All kinds of data. Before the telescopes go online, you can get a countdown pretty much by clicking on, I'm going to Chile because they're not online yet. What does this tell me? We're going to get clouded out. We're not going to have Chile telescopes tonight. So a lot of very dedicated people check this before they plan a night of observation, especially if they want to take live photos. This doesn't look promising. And let's go to observatory information. I'm going to close that. It gives me all this great info. Sky conditions, most important, level 1. That's the worst. That means you've got clouds for 70% of the missions. You have other information here, dew point, humidity, temperature. Wind speed is an issue because especially with like Canary 1, it's a large telescope. It's very susceptible to wind. We're finding about humidity. Current humidity is 85%, which is above the operational limit. That's a problem. And we can track humidity and astronomical twilight, civil twilight, and all that type of stuff. This is definitely going to be a wash. I don't see these coming up online. But usually if we see sky conditions at a level 3 or better, we'll have telescopes for that night, unless we have wind. And the sky conditions really have more to do with seeing and transparency, which is, the conditions of the atmosphere and not wind as much. So it's a lot of information packed into a couple minutes, but I hope that helps. You will learn as time goes on. You'll get an intuitive feel for when the telescopes are going to open, of where your information winds up. But I think that's a good place to start. If you ever want to find your photos, like I said, just go to My Photos here, and you have them all here in your photo roll. These are all the photos from missions that maybe you joined or pictures that you took live. They're all going to be here. As I mentioned, if you just join at the top of the web page at the dashboard, you can also just scroll down. All your pictures are there. Last, I don't even want to. I think my computer might start to smoke if I go to last. All right, so what do I have? I have a lot of pictures. That's like way too many pictures. But you can click on one and see what it is that you have saved. Hey, not bad. Popular cluster. Beautiful. Any other questions on this? It's always good to backtrack and go back to our workflow and see how other people do things on Slooh, because everybody does things a little bit differently. I think one big takeaway here is that you can open up more tabs. You don't have to go from telescope to telescope to telescope. You can do a Canary 2. And as I said, you can do a Canary 4. How about this? I'll do a Canary 2 wide field. And we'll do, and the other one, Canary 2 ultra wide field. And we'll see the difference between the two. It's all field of view. One will give us a nice wide part of the sky, and the other will be slightly narrower. So here's some type of what we're looking at. It's not Sirius. Sirius is a minor planet. So we have that, and then we have this. It's the same object, just a different field of view. There are 2 telescopes. And if you join a mission like I showed you, you will get images from both telescopes. You don't have to toggle back and forth between them. It does it for you automatically. I need a break.
So
Questions, you
thank you,
guys?
but I just have one last question.
Sure,
can
no,
you
go ahead.
just, is it possible for you just to orient the telescope to like whichever coordinates you want if you want to observe something?
Absolutely. So
That's cool.
let's go into my mission setup. Now, there are differences to how many times you can do this, depending on the membership level that you have. But unless I'm mistaken, every membership level will give you at least one advanced mission, and that's what we're talking about here. So let's take a look at these. I'm going to go to mission setup. Now, for Astronomy Camp, we've been scheduling most of our missions as Slooh 1000 missions, but you don't have to do it that way. You can schedule by catalog, and these are advanced missions. I think every level, even student levels, will give you one advanced mission at a time, which means if you schedule an advanced mission, I want to do we'll do a sharpless catalog. I can't think of any sharpless numbers right now, but anyway, you schedule a mission. When this mission runs out, you can schedule another one. So you have to kind of be careful with how you schedule your missions. And this is true of any mission that you schedule. You are allowed X number of missions depending on the level that you're interested in. So let's see, 136, let's type it in. I'm going to schedule this right now. So if you know that the object is visible, and okay, so what is sharpless 136?
Wait, let me just check. Sorry.
Because we do have processing, you can
Yeah,
choose.
it's the Ghost Nebula. It's the Ghost Nebula. So it's a reflection.
I'm going to call that faint nebula because reflection nebula are usually faint. And preview mission, we're going to schedule. Now, see, here's the thing. This mission won't run until tomorrow, 15 UTC. So you can calculate back to whatever UTC time is. Some of these missions might show up several days. So if you burn your one advanced mission, you have to wait several days until that runs. So you can get clever and kind of figure out ways to maximize how many of these missions you can get. So, ideally, this isn't too bad. This is going to run not long from now. But sometimes you will see where a mission will run 4 or 5 days in advance. That means you have to wait for that mission to run before you can schedule another one. I'm going to schedule it anyway. Let's look at coordinate missions. So we can go by Slooh 1000, constellation, catalog. We can go by telescope. This is where we schedule a coordinate mission. First thing is you have to look for an open slot, and this is where we schedule our coordinate mission. And it types it in hours, minutes, seconds, and that way, and it will convert the coordinate mission to decimal. So that's another thing. So when we go back and look at the queue, I know this is all advanced stuff, but you'll get the hang of it. I'm just going to look down. Now, don't forget, any one of these missions with the 3 dots, you can join. It's only if you want to schedule your own mission. If you don't care what you're going to. So, for example, I don't know where this is. The recommendation was that people who are scheduling coordinate missions to put in their description what it is we're looking at. I'm not sure what this is, but I'll schedule a mission there anyway. I'll join it. I don't have to sit and watch this mission live. The pictures from this mission will show up in my photo roll. Here's another one. So this is the supernova that we have in M101, the pinwheel. That's its number, SN 2023 IXF. I don't even have to be there to watch this. These images will show up automatically in my photo roll. And that's true of any of these. So what's the advantage of watching a mission live? Well, sometimes we get better images coming out of the camera, or different images coming out of the camera, depending on settings and wind and that kind of thing. So when you get those robo snaps, that's what we call them, images, sometimes you'll get images, a lot of times you'll get pictures that are actually better if you had watched the mission live. You'll see this with things like the moon. Sometimes the moon will tend to overexpose. So if you catch a mission earlier, you may get a better picture of the moon than if you just get the RoboSnap. Let's say the RoboSnap occurs later and there's some overexposure. We definitely get this when we do things like any type of planetary event, like a conjunction of Venus, Saturn type of thing, or the Great Conjunction Jupiter, Saturn. When you have a very, very bright object and very dim object, something is eventually going to go wrong. In order to see the dim object, a brighter object is going to be overexposed. You'll see this in Jupiter's Galilean moon missions. These are ones that help to watch live because the planet is so much brighter than its moons, especially now because Jupiter is farther away from us. It's listed as a planet mission. I'm going to schedule on Jupiter's moons, Galilean satellites right now because we're still opposition with Jupiter. I have written down is not until November 3rd. So the planet is going to appear a lot brighter than the moons. So this is a mission that would help to watch live so that the whole thing isn't blown out. I'm just thinking out loud now and trying to be helpful. Keep bringing these questions up, experiment a little bit, and you will eventually find your way and feel your way through this. It's not easy in the beginning. It's easier for some than it is for others. But, we get these types of questions all the time, and there's no shame in not knowing simple things like knowing that there are 2 telescopes at the Canary Islands, because I didn't know this for at least a year. When I started, I don't know, it didn't make sense to me. I didn't get it. And I never really thought about why we have 2 sets of pictures. It just didn't register. So it does take time, but you'll get the hang of it. And reach out on Discord. If you're not a member of Discord, I recommend everybody here to join. I don't know if Grace is still here. There is a special student group if you are a student member, where you have your own space on Discord, where it's students like yourselves. And Grace, why don't you type in again for us, if you can't unmute, the easiest way for students to join. I don't know if that's what comes automatically with the membership, or if you how you do that. Okay, so I'm going to click my profile. I can't join, but it will show you how you do it anyway. It's called My Community. So if you're not a student in the student group yet, you have to join it. So somewhere down here, it will tell you how to join. Press join our Discord server. I am already joined, so I say leave. I don't want to leave. So if you don't see that, you want to click on join the Discord server, and that will put you into House Cygnus, which is our student run by students for students on Discord. It's a lot of fun. I know that for the grown-ups, I can't imagine not being part of Discord. We exchange so much information. It's really overwhelming. Discord took over the old Slooh chat box, if you were around long enough to remember that. Discord is the much greater and improved version of that. Guess what, you guys? It's 6 o'clock. I'm going to stop sharing. We talked about
Today's class went by so fast, Keith.
I'm glad we got to cover some of this material. Always ask questions. When we get into galaxies, these aren't, they're far away from us, especially things like elliptical galaxies. We'll talk about interacting galaxies tomorrow. There isn't really a whole lot to talk about. So this is a good time to talk about, answer some of the questions that you may have, and to talk about some of these other things. We're not going to have as much time when we talk about the moon, because there's tons of stuff to talk about the moon. And I certainly want to encourage everybody, and I'm going to share the Apollo 11 live site, where you can take your own simulated mission to the moon on July 16th, which is the anniversary of the Apollo 11 launch. And that will be Sunday. And you can follow along the moon mission exactly as the astronauts did. And we'll take a look at that. You can take part in some of the footsteps of Apollo quest And we've got tons of information to cover about the moon. To enrich your understanding and enjoyment of the Earth's only natural satellite, there's so much to look at the moon. Visible with the naked eye, binoculars, very inexpensive telescope will give you amazing views of the moon live. And of course, it's probably one of the most popular objects here on Slooh. We see a lot of moon missions. So we are going to help you with that next week. Tomorrow, we'll talk some of the interacting galaxies and maybe some of the irregular galaxies. And then if I have time, I will put together a Kahoot for Thursday. Got it. Thank you, everybody, for coming. Keep the questions coming.
Kane has a question.
Put it in the workspace. Yes, Kane, go ahead, and we'll have you take us out.
I was gonna say, here where I live, it'll be a big thing about the Apollo 11 launch, because I live maybe about an hour away from Cape Canaveral.
Cool.
How old are you, Kane?
10.
I was at Cape Canaveral twice when we were still going to the moon, when I was about your age. So yeah, it's a big deal. But we'll talk about that. So any questions, like I said, reach out to Artemis, reach out to Grace on Discord, join Discord and become part of that group. We learn from each other. That's what Slooh is about. It's just such a great resource that, a year or two ago we didn't have. So become part of the community, interact with each other, and we'll see you back here tomorrow. We're going to talk about galaxies which interact and galaxies that are slightly irregular. Thank you all for coming. Have a great night. We'll see you tomorrow.
Bye, everyone.
Bye.
you.
Thank you for having me.
You're